I'm going to be covering homework 21 answers, and I'm going to go through 16, 18, 20, 22, 65, and 67 in that order. So, implicit differentiation. We are going to take the derivative with respect to x of both sides of the equation. On the left side, I want to see that I have a baby function inside of a square root. I'm going to erase this that I wrote to be able to see that a little bit better. So, baby function, and I chain rule, but first I look at the mommy. The mommy is the square root of bleh, which means bleh to the 1/2 power. The derivative using the power rule is 1/2 bleh to the negative 1/2 power. Then the chain rule says, give mommy her baby, and then multiply by the derivative of that baby. And when I hit that multiply by the derivative of that baby, that becomes my new focus. I do not need to concern myself with that square root that I saw any longer, but I am still, with respect to x, taking this derivative. So, over addition, I differentiate separately. Derivative of x with respect to x is 1. Derivative of y with respect to x is dy dx. Then I move over to the other side of the equal sign. Derivative of 1, adding two things, 0. Just going to move on. Now I need to take the derivative of x squared times y squared. I have to use the product rule. So I'm going to first skeleton it out. And I'm going to say I'm going to keep x squared, and then I'm going to multiply by the derivative with respect to x of y squared, plus, continuing with the product rule, I will take the derivative of x squared and multiply that by y squared. So I will keep the y squared, and I will multiply by the derivative with respect to x of x squared. And it doesn't matter what order I multiply in. So, with respect to x, taking the derivative of y squared, I've got to see y as a baby function needing the chain rule. And the mommy is bleh squared. I start off with the power rule. Derivative of bleh squared is 2 times bleh. Then I move to the chain rule, where it says give mommy her baby and multiply by the derivative of that baby. Well, with that baby being y, its derivative with respect to x is dy dx. And then over here, taking the derivative of x squared with respect to x, I get 2x. Now, on these problems, I am supposed to isolate dy dx so that I can solve for it. And I'm going to have to do some simplification. I need to distribute over this addition, this multiplication. And while I'm distributing it, I'm going to realize that this is really just a big denominator. This is really just 1 over 2 times the square root of x plus y. So, multiplying that over these two, I get 1 over 2 root x plus y plus dy dx multiplied by that 1 over 2 root x plus y. On the other side, I'm just going to rewrite it 2x squared y times dy dx plus 2x times y squared. Once I hit this stage, I am looking for where is dy dx and who is it multiplying directly to in between any addition, subtraction, or equal signs. I want to get those two together on one side of the equation and who isn't underlined together on the other side of the equation. So I'm going to move this over to the left. And then I will have 1 over 2 times the square root of x plus y minus 2xy squared equals And on the right side, I already have 2x squared y times dy dx. And I'm going to subtract from that, bringing this over, dy dx times 1 over 2 root x plus y. Now I'm going to be factoring out the dy dx. And I see simplification in your future. A lot of simplification. I'm going to move number 18 away so that I've got, whoa, come back. I'm going to move 18 away so I've got a little bit more room for this simplification that I see coming on. So I'm going to rewrite what I have on the left side, but I'm going to prep it for the common denominator bit. I'm going to be factoring out a dy dx and prepping for a common denominator bit while I'm at it. Okay, there's dy dx factored out. Now, I can, if simplification doesn't matter, just divide by this big giant square bracket over to the other side and I'm done. But let's look at dealing with the simplification. Okay, come on, come back to life. There we go. So to do common denominator, I need to multiply and divide by 2 times the square root of x plus y. For this fraction over here, same thing. So now on the left side of the equal sign, I have my common denominator of 2 times the square root of x plus y. And then I bring the numerators together with the addition or subtraction. And that's going to give me 1 minus 2 times 2 will give me 4. And x times a y squared times a square root of x plus y. On the right side, I have my common denominator. I do still have my dy dx over here. And then my numerators are 2 times 2 is 4 times x squared y times the square root of x plus y minus 1. I can multiply both sides by that common denominator and kill it. And then my dog just looked at me with a look. He's confused. Okay. So all I have left to do is divide. So 1 minus 4x y squared times the square root of x plus y that I see on the left, divided by this 4x squared y times the square root of x plus y minus 1, and that is equal to dy dx. Whee! One down, a few to go. Number 18. Taking the derivative with respect to the x variable. I see a little baby function. So I'm going to have to chain rule, but I look at the mommy function, it's tangent, and I ask what's the derivative of tangent of blah, and you say secant squared of blah. Give mommy her baby and multiply that by the derivative of that baby with respect to x. The derivative of x with respect to x is 1 minus the derivative of y with respect to x. On the other side of the equal sign, I need to start everything off with quotient rule because I can see that I have two functions dividing. So it's time to get loaded on some math. Make sure you make that pronunciation. So we have Lodi high, low D high. So I'm multiplying by the derivative of high, and that is a y. I'm taking the derivative with respect to x. That means I am getting dy dx. So now I have low d high minus high d low. For d low, everything is in terms of x. I'm differentiating with respect to x. Derivative of 1 by itself will be 0, and then derivative of x squared will give me 2x. Square the bottom, and away we go, but not, because I'm supposed to isolate dy dx. So here we go. I need to do some serious distributing. And I want to avoid fraction land while I'm at it. To avoid fraction land, I can take this denominator, multiply it to the other side, and then distribute a whole big giant mess of a function. So multiplying this to the left, I now have 1 plus x squared, quantity squared, multiplying to the secant squared of x minus y. And I need to distribute both of those together over this subtraction. And with what I'm seeing there, I'm going to save my time. Distributing this over, first I multiply by 1, there it is, minus it times dy dx. And then on the right side, 1 plus x squared times dy dx minus 2xy. Now, since I've got a computer screen, I can just shrink it down to deal with it being too long. So once I get to this step where I've simplified everything and I have separate terms where some of the terms have dy dx as a factor, other terms do not have dy dx as a factor. I need to look at the entirety of the terms that do have dy dx as a factor, and I need to combine them. So what I'm going to do is I'm going to add this to the other side. When I do that, I am going to have, I already have the 1 plus x squared times dy dx. And then I'm going to add this over so that I have a 1 plus x squared times, 1 plus, be careful. I'm trying to make sure I'm not messing this up. Okay. I got a 1 plus x squared and a 1 plus x squared squared. And I need to not mix them. Hopefully I have not done that already. I am trying to be very, very careful with my steps. So that is taking this bit and subtracting that bit, or actually adding, I should say. And then on the other side of the equal sign, I have what's already there, 1 plus x squared quantity squared times secant squared of x minus y. And then I need to bring over this negative 2xy by adding it. At that point, you're going to be able to factor a dy dx out of that right side. When you factor it out, you will be left with a 1 plus x squared plus a 1 plus x squared squared times secant squared of x minus y times the common dy dx. Finally, my last step is to divide this big giant parentheses to this. So now I have that left side is 1 plus x squared quantity squared times the secant squared of x minus y plus 2xy. And then I divide by this mess, which is 1 plus x squared plus 1 plus x squared squared times the secant squared of x minus y, and that is equal to dy dx. I'm going to be honest with you, I'm not going to double check this answer. So if I have made any algebra mistakes, please let me know in the comment section of Google Classroom where I post this. Alrighty, now we're going to move on to number 20. I've got to move some of these creatures out of the way. And I'm going to erase some of this. You can always rewind the video and take a screenshot. If you're hearing the sound effects, you probably should have fast forwarded. Here we go, number 20. I am taking the derivative with respect to x. So I'm going to make this just a touch bigger. Over addition, I differentiate separately. The derivative of sine x with respect to x is cosine x plus sine. Then I have cosine y, but I'm differentiating with respect to x. So anytime I have a variable that is not who I'm differentiating with respect to, I'm going to circle it and call it a baby function with a chain rule. So I am now taking the derivative of cosine of blah. The derivative of cosine of blah is negative sine of blah. And I'm going to give mommy her baby and multiply by the derivative of that baby with respect to x. On the right side of the equation, I have multiplication between these two functions, so I'm going to have to product rule this out. As I product rule this out, I have keep one function, multiply by the derivative of the other, plus swap it out, multiply by the derivative of sine x to get cosine x, and keep the cosine y. And then I waited for this one because it's going to be a little bit more work. Actually, I'll do purple. So taking the derivative of cosine of y while you were in the middle of a product rule. First of all, treat that as a baby. Derivative of cosine of blah is negative sine of blah. Give mommy her baby. Multiply by the derivative of that baby. And we have completed the differentiation part. Now I need to simplify maybe a bit and get my terms together. Isolate that dy dx. And so taking a look at it and carefully simplifying, I have a plain old cosine x minus a sine y times dy dx equal to, however much you want to bring those together, don't, negative sine x times sine y times dy dx plus cosine x times cosine y. Look for your dy dx's. Look at who they are factors in, and then start that isolation process. So I've got my cosine x, and I'm going to subtract over this cosine x times cosine y. Then on the right side, I'm going to need to add this negative, or this sine y, times dy dx. So as I add that over, it becomes sine y times dy dx. And then I have over here on the right already minus sine x times sine y times dy dx. And I can factor the dy dx out on the right side. And actually, why don't I, while I'm at it, factor out a sine y? So I've got sine y times 1 minus sine x times dy dx. On the left, if I feel like it, I can factor a cosine x, and that will leave me with a 1 minus cosine y. And I'm ready to wrap this problem up. By division, I end up getting that dy dx is equal to cosine x times 1 minus cosine y divided by sine y times 1 minus sine x. And I don't know if the textbook simplified from there. If they did, let me know and I can add that on. But that's good enough. Let's move on to 22. For 22, I need to deal with the fact that I've got known functions mixed with generic function, g of x. And I'm supposed to find g prime of 0. What I'm going to do is I'm going to erase up here a little bit so I can move this up and not interfere with having to move the other problems. Okay. Move. And here we go. Implicitly taking the derivative of this left side with respect to x. With respect to x, the derivative of g of x is g prime of x. Then I have my plus sign. And then I need to look at this very, very carefully. I have x times the sign, and then I don't see an x right after that sign. I see a g of x right after that sign. That means I've got a baby function in my sign. Now, I have to start off with the fact that I have two functions brought together by multiplication and use the product rule. While I am taking the derivative of the second function, it has a baby inside of it, and I have to chain rule. So here we go, starting with product rule. I am going to keep the x multiplied by the derivative of the other, let's come back to that, plus the derivative of x with respect to x times, keep the second one, and that second one is sine of g of x. Now, right here, I'm going to need to take the derivative with respect to x of the sine of g of x, and I need to recognize that this is a baby function inside of sine. So I start off with, who's the mommy? The mommy is the sine of blah. When I take the derivative of sine of blah, I get cosine of blah. So cosine of blah. Shove baby in, multiply by derivative of baby. That's the left side. On the right side, I have x squared. Taking the derivative of x squared with respect to x, I got 2x. Now, I'm going to erase saying that I need to take the derivative. And what I'm going to do is realize I have an equation, and I'm going to plug 0 into every single x that I see. That means this is g prime of 0 plus 0 times, oh my goodness, 0 times 0 times who? I don't care. 0 plus 1 times the sine of g of 0. And that is equal to 2 times 0, so 0. Now at this point, what I have is g prime of 0 is equal to, subtract this over, the negative sine of g of 0. And I'm going to put a parenthesis around that g of 0 just to make it a little bit more clear. Now, here's the thing. If I look at this original equation, can I solve for g of 0? Okay, well, I can't. There we go. So I'm going to take this right here, and I'm going to put 0 into every single x, and I just realized that I wrote that too far out. So I'm going to try that again. This is the equation. I'm going to plug 0 into every x that I see. So that means g of 0 plus 0 times, who cares, is equal to 0. Hey, looks like g of 0 is 0. Now, if I know g of 0 is 0, then I'm going to go back to, I'm going to move this up a little bit. I'm going to go back to this equation. G prime of 0 is equal to negative the sine of g of 0, and g of 0 is 0. Then what's the sine of 0? 0. So I get negative 0. Wait, that's just 0. It's almost cruel. I just get nothing. That's what I get out of all that work. Wasn't that fun? And if I messed up in the problem again, please tell me in chat, because I'm not going to take the time to double check the answers. Move that out of the way. Okay, 65. Let's get this done. I'm going to erase the stuff up here so that I can move 65 up a little higher. No, don't clear canvas, please. Thank you. All right, 65. Here we go. The equation is right here. Maybe I should make this a little bigger. I'm supposed to find all the points on this curve where the slope of the tangent line is -1. So the first thing I've got to do is find slope of tangent line. Slope of tangent line means I need to know what dy dx is. Once I find dy dx, I need to set that equal to -1, and then I need to solve. But first I've got to get to dy dx. So here we go. Taking the derivative with respect to x of this first bit of the expression, x squared times y squared. Those two functions are brought together by multiplication, so I need a product rule. That means I have keep the x squared multiplied by the derivative of the other, plus keep the y squared multiplied by the derivative of the other. Now, I'm going to start over here with times the derivative of x squared with respect to x, 2x. Over here, though, I need to be a little careful. I'm taking the derivative of y squared with respect to x. There's no other way I'm going to get dy over dx but to take the derivative with respect to the x variable. So I need to see y as a baby, and the mommy is blah squared, and I take the derivative of the mommy, and I get 2 times blah. I give mommy her baby, multiply by the derivative of her baby with respect to x. And I have completed now that product rule. Then I have this addition sign right here. And then I look at the next piece and go, oh goody, another product rule. What? I wasn't getting enough of it. Here we go. So I've got keep the x, multiply by the derivative of y with respect to x, so dy dx. Continue with product rule plus keep the y, multiply by the derivative of x, that's 1. And then on the other side of the equal sign, I have 2. Taking the derivative of 2 with respect to x, it's a constant, so 0. Now I need to isolate my dy dx. So I need to look at where do I have dy dx. And I can see that this dy dx is multiplying by all that stuff. This dy dx is multiplying by the x. And I can do a separate and divide. So I'm going to keep these dy dx's on the side I have them on. That means I have a 2 times x squared times y times the dy dx plus x times the dy dx. So I'm factoring that out. And then I'm going to take these two and I'm going to subtract them to the other side of the equation. So I have minus 2xy squared minus y. And then I'm going to divide and I will be done. I'm going to pull that negative sign out, and then it is 2xy squared plus y plus y. And then that will be divided by the 2x squared y plus x. I'm going to leave it there. And there is one more, and the inverse. Oh, okay. When I get these inverse problems, I first search for the question. The question says find that. Let me erase it so I can see it better. I'm going to make it big so I can see it better. And I am being asked to find the derivative of f inverse at x equals 5. So for me, I make my table where I have f inverse. The point that matters to me is the point where it has x coordinate 5. So I've got my corresponding points. One of my functions is f inverse. The other function is f. So what I know just from this alone is this much, just from that one statement. So now I'm going to go and look at what I have here. And what I have here, I am told that f of 4 is equal to 5. Well, there's my 5y value. That means 4 is my x coordinate of f that matters. Then I'm going to look at slope. What do I know about slope? I know that the derivative of f when it has x equals 4 is 2/3. So I'm going to say the slope of f at 4 is 2/3. Now the slope of f inverse at its x that corresponds, 5, This must be equal to the reciprocal of its inverse function's derivative at the corresponding point. That means 3/2, voila, done. Woo! Hopefully I didn't screw up any of those problems, but if I did, again, leave a comment in where I have this posted. Good night, farewell. I will see you on the other side of, oh no, wait, I'll just see you on the internet.